Hello children, how are you all? I hope you are all safe at home. Now coming to the our session, today we are going to discuss real numbers and their decimal expansion. The previous session we discussed already what are the rational numbers, irrational numbers, okay? The combination of rational and irrational are called real numbers. Then how to represent the irrational number on the number line. Clear my dear sir? Okay, root 2, square root of 2, square root of 3 we discussed in the previous session. Now coming to here today, real numbers and their decimal expansion. Let us discuss some examples. Now first one is 10 by 3, second one is 1 by 8, and the third one is I am going to find out 1 by 7. Now look at here everyone. Look at this. Clear? So now here in this little bit this is 7 by 8, sorry, right, 7 by 8. Okay, now I am going to divide each and every value in a long division method. Now observe clearly everyone, see the remainders, all of you. Now see this, when you divide 10 with 3, okay, 3 3s are 9, when you subtract 1 will become, so keep the decimal point, keep 0, again 3 3s are 9. When subtract, you will get 0, decimal is there, keep one more 0, and 3 3s are 9, so it will become, again it is repeated. Clear? Now this is the first one. Now coming to this one, for the second one, when you divide 7 with 8, 7 is not possible in 8 table, because 7 is less than the 8, so you take 0 point decimal, and keep 0 here. Now 8, how many times will become? 8 9s are 72, 8 8s are 64. Okay, 8 8s are 64. When you subtract 70 minus 64 is 6. Okay, decimal is there. Keep 0, 60. 8 7s are 56. 8 7s are 56. When you subtract these 60 minus 56 is 4. Again decimal is there. Keep 0. 8 5s are 40. Now 40 minus 40 will become 0. Clear? In this case we got 1 as a remainder, repeated, here 0 as a remainder. Now coming to the third one, in the third one, if you observe this here, when you divide 1 with 7, 1 is not possible in 7 table, so take a 0 point decimal. So 10, so 7 ones are 7, this will become 3, decimal is there, 0, 7 fours are 28, okay, subtract, this will become 2. So 0, 7 2s are 14. Clear my dear? 7 2s are 14. 20 minus 14 is how much here? This is 6. 0. Again 7 7s are 7 8s are 56. 7 8s are 56. Again 0. So sorry 4. 60 minus 56 is 4. 0 40 is there. 7 5s are 35. Okay. When you subtract, I am going to do here. Now 40 minus 35 is 5. Again decimal point 0. 7 7s are 49. Clear? Subtract 1. So 1 is again repeated. 0. 7 1s are 7. Again 3. Now see this here. This is repeated process. Now observe these 3 divisions. You have to observe these 3 divisions. In the first case 10 by 3. When you divide 10 by 3, you will get 3.333. You are going to get 1 is the remainder. Only one value is repeated. 1 1 1 1. If you do it n number of times, infinity times, you get the remainder as 1 only. The question will become 3.333. Coming to here, the second case, when you divide 7 with 8, okay, it is nothing but 70. It is end with remainder 0. Okay, after some values, after some repetition, after some values, the value will become, remainder will become 0. Here remainder is not equal to 0. Now coming to here, in this series here, observe this special case. When you divide 1 with 7, when you divide 1 by 7, okay, you will get series here 1 4 2 8 5 7. Here this part, if you observe this part, clear, that value is repeated once again and again and again and again. That means here, in the first case remainder is 3, second case is 2, third case is 6, 4, 5, again 1, then again 3. So whatever we got the remainder in the first case, we got remainder again in the last case also. Means we are stopped here the division part. If you do again we can same quotient here 1 4 2 8 5 7 again, and remainder should become 3 2 6 4 5 1 3 again it is repeated. Okay, now in these three cases here remainder will become always 1 1 1. So what is the remainder here? Remainder will become 1 1 1 etc etc. Here remainder is 0. What is the remainder here? Remainders. So in the first case we have, that is here it is 6 comma, in the second case we have 4 then 0. Means after 3 steps we got remainder is 0. Now in this case reminders are here, see this here, observe. The first case, in the first division we have 3, the next case is 2, the next case is 6, again 3 2 6 4 comma 5 comma 1 again 3. It is repeated again. So these digits 3 2 6 4 5 1 are repeated once again. Clear? Did you observe all these things? Now we can conclude from these three statements. What you are going to conclude? Either remainder will be 0 or remainder will not be 0. That is the first case. What is that? Either remainder will be 0 or remainder will not be 0. Then what is the second case? In this case, remainder it may be repeated. Okay, here remainder will be repeated and quotient will be only one digit is repeated, 3.33333. But coming to in this case, remainders are different values, and as well as even the quotient is after some digits the quotient will be repeated. After some digits the quotient will be repeated. Okay, now we are going to discuss these three cases in detail. Now, just now I told you, so based on those three divisions, long divisions, we got 3 points. One is, see this here, first one is, the remainder either becomes 0 after a certain stage, that is 10 by 8. Second example is the example for this. So, when you divide 10 by 8, after 3 places, after some time, the remainder will become 0. Or start repeating themselves. Or see that for this example 1 and 3 are examples. Clear? Repeated after start repeating themselves again. Clear? So now the second point is the number of entries in the repeating string of reminders is less than the divisor. Clear? For this is here I am going to explain. In 1 by 3, when you divide 1 with 3, you will get, see this here. 3 3s are 9. What is the remainder here? 1. Again 3, 0. 3 3s are 9. So here 1 is repeated, and this 1 is less than the divisor. Also, now in this third example also, when you divide 1 with 7, 7 ones are 7. This is 3. Okay, point here. 7 4s are 28. So again this will become 20. So now I am going to do here 20 7, how much it is? 7 2s are 14. So when you subtract 6 again 0, 7 8s are 56. So again 4. Now if you observe in each and every case, in the first case 3 is the remainder, the second case we got 2 is the remainder, 6 is the remainder, 4 is the remainder. So that will become here 40. So when you divide this 5, okay, 7 5 is 35. Again 5 is the remainder, 50. 7 7s are 49. Again 1 is the remainder. Clear? Again if you keep 1 means 1 only. So if you keep here 1, again 7 1s are 7. Again remainder is 3. Now if you observe this in this case, the number of entries in the repeating string of reminders is less than the divisor. In observing these two cases, in this case, reminders, in this case what is the remainder? Again, if you take one more 0, if you take one more 0, again we get 3 3 is a 9. Again, remainder will become 1. So whatever we got the remainder here, it is the less than the divisor. Even though it is repeating string, the remainder of this case is less than the divisor. Coming to this case, here the reminders are we got what is that? 3, 2, 6, 4, 5, 1, 3. Again, see this here. This is the repeated values. These are the reminders in each and every step we got. Now observe, these are all the reminders. 3, 2, 6, 4, 5, 1 are less than the divisor. Here less than divisor is nothing but 7. That we can have to observe. Even though if it is the remainder is not equal to 0 and the start repeating themselves, okay, the reminders are repeating and repeating. Clear? Whatever we got the reminders are less than the divisor. Is clear, my dears? Now coming to third point, if the reminders is repeat, here 3 is repeated, so here 1 is repeated, here 3, 2, 6, 4, 5, 1, again 3, 2, 6, 4, 5, 1 is the repeated. Clear? Then we get a repeating block of digits in the quotient. Clear? In this case, in the first example, in this case, see the quotient here. Quotient will become 3.333 only we got. Now coming to in this case, quotient will become, see this here. Now I am going to write here, quotient is equal to, what is the value? 0.142857. 142857. Again 142857. Clear? So this is a value is repeated again. Now see this here. If the reminders are repeat, then we get a repeating block of digits in the quotient. In this, which block is repeated? 3 is the block is repeated. Now in this case, this is 142857 is the block. Okay. Once again you have to do division one more time or 3 or 4 or 5 infinite times you have to do. These will be repeated. This is the block of digits. One block of digits will be repeated again and again. So these are the 3 points we are going to find out. We can recognize from this. We can find out. We can observe from those examples. Here it may be either 0 after a certain stage or start repeating themselves. Clear? Now second case is the number of entries in the repeating string of the remainder is less than the divisor. That also we discussed. Now third point is if the reminders repeat, then we get a repeating block of digits in the quotient. What is this? If the reminders are repeated, then even though I mean to say that if reminders are repeated, then the quotient also will be repeated. Whatever the digits are in the quotient will be repeated. Is clear, my dears? Okay. Is it possible in all the way? Is it possible in all the rational numbers P by Q form? Is it possible or not? Let us discuss. Okay. Now we are going to discuss 2 cases here. If the number of, if the remainder becomes 0 or remainder will not become 0. That we are going to discuss now. Is it clear, my dears? Did you understand this? Right. Now, children, so just now we discussed that 2 cases will arise. If remainder will become 0, what will happen? If remainder is never become 0, what will happen? We are going to discuss now. Now see this here in the example. In example 7 by 8, we will divide 7 by 8. What will happen here? After some time, the remainder will become 0. Clear? Now see this here. In this case, in 7 by 8, after 3 steps, we got remainder as 0. Remainder as 0. See this here, remainder will become 0. So 7 by 8 will become 0.8. 875. Here there is no repetition. Clear? After some time the remainder will become 0. Then this type of numbers are, this type of rational numbers are called which type of numbers? So now, so therefore, so these type of rational numbers, these type of rational numbers are called terminating decimal, are called terminating. Means after some time, after some steps, the remainder will become 0. Terminating means end with or ends with 0. Ends with 0. Clear, my dears? So whenever you get remainder is 0 after some time, after some places, after some repeated values. Clear? So then this is called terminating decimals. This is called terminating decimal values. Clear, my dears? Or end with 0. Clear? Now coming to here there are two examples are there. One is 10 by 3 as well as 1 by 7. In 10 by 3, the value will become 3.33333, and 1 by 7 will get 0.142857. Clear? This is the repeated values. Now see this here. Here in this case the remainder never end with 0. Remainder is never end with 0, and here the same question will be repeated. Same question will be repeated. That is, which is nothing but this can be written as 3.3 bar also. 3.3 bar. Now in this case, it is nothing but certain digits are repeated after some time. That is 142857 is repeated after 6 digits. Again, if you start after 7, again it will become 142857. So in this case, we should write 142857. This is totally bar. So this is nothing but what type of these numbers are called? These numbers are called. These are never become 0. The remainder is never become 0. So all numbers are called. So these numbers are called. These type of numbers are called. These numbers are called non-terminating recurring or repeating. Means here it is repeated after the 3 is repeated here, 142857 is repeated again. So these type of calls are non-terminating recurring decimal. Non-terminating recurring decimal. One is a terminating decimal, second one is non-terminating recurring decimals. Clear, my dears? Did you understand this here? When the remainder becomes 0, these type of numbers are called terminating decimal numbers, and these type of numbers called when the remainder is never become 0 and the question will be repeated. Clear? So these type of numbers are called non-terminating recurring decimal or repeating the decimal value. Is this clear, my dears, everyone? Is this clear? So based on this we are going to discuss some examples. Now, see this is example 6. Show that 3.142678 is a rational number, or express 3.142678 in the form of p by q, where p and q are integers, q not equal to 0. So very simple. Okay. Solution. Now given that 3.142678. Generally in lower classes already we discussed. If you want to remove this decimal, you should write 1 in the denominator, and after decimal point, how many places are there? 1, 2, 3, 4, 5, 6. That many zeros you will get. That many number of zeros you will get in the denominator. So now, which is implies this here? 3.142678 can be written as I'm removing this decimal point. I'm going to write total number 3142678 divided by, for the decimal point you should keep 1, and how many places are there after decimal? 1, 2, 3, 4, 5, 6. So there are 6 zeros we get 3, 4, 5, 6. Now see this here, observe here this number 3142678 is integer divided by 1, 2, 3, 4, 5. This is 10 lakhs. Clear? 10 lakhs. Something this number by this is nothing but both are positive, both are integers. This number is satisfy the condition or not. So therefore 3.142678 is a rational number. Is a rational number. This is clear. Is a rational number which is equal to what is the answer? 3142678 divided by 10 lakhs. That is 6 zeros. This is clear, my dears? So this is a way to represent any decimal number in the form of p by q. Now let us discuss question number example 7. Show that 0.3333 is equal to 0.3 bar can be expressed in the form of p by q and q. Now let us see this here. Example 7 we are going to discuss. What is example 7? Show that 0.3333 which is equal to 0.3 bar is a rational number. Is a rational number. How to simplify this one? Now see this all of you. Listen carefully. A solution given that let us take that let p is equal to or x is equal to, let us take that x is equal to 0.3 bar. Is clear? Here how many digits have bar? How many digits have bar here? Only one digit have bar. So you should multiply with 10 on both the sides. Okay? So multiply with 10 on both the sides. 10 on both the sides. On both sides. So you will get here, which is implies 10 into x is equal to 10 into 0.33. Clear? 0.333 dash. Now which is implies 10x is equal to, when you multiply with 10, the decimal point will move to the one step will move to the right hand side. So this value become 3.3333. Clear? When we multiply a decimal number with 10, the decimal point will jump one step to the right hand side. Clear, my dears? So it will become 3.33. Now this is a 10x and x. Let's subtract x value from this. Okay. Now what are you going to get here? See this here. So these are all 3 all will become 3 only. 3 all will become 0. So 3 minus 0 equal to 3 only. Clear? Which is equal to 10x minus x is equal to 9x. 10x minus x is equal to 9x. That is 10 minus 1 equal to 9. X will become x only. Now which is implies x is equal to, this man you have to transpose to right hand side, will become 3 by 9. When you cancellation given the division. So therefore x is equal to how much we got? 1 by 3. X is equal to 1 by 3. Is it clear, my dears? So 1 by 3, it is in the form of p by q or not? It is in the form of p by q where p and q are integers and q not equal to 0. Whether this is satisfied or not, the condition, rational number condition. Okay, so therefore 0.333 bar is a rational number. This is clear, my dears? So this is the process to find out. Here there is no repetition. In this example, there is no repetition. After 8, at the 8, the remainder will become 0. That's why we got this total value divided by 10 lakhs directly. We got as a rational number. Coming to here, it is a non-terminating recurring decimal. It is a terminating decimal. This is non-terminating recurring number. Clear? So for this number to convert into rational number, okay, you need to do this process. Now, what we are going to multiply with 10 or 100 or 1000? It depends on the bar of the numbers. Here only one digit I have one bar. So that's why we are multiplying with 10. Clear? So now just multiply with 10. You simplify. You get the value as x equal to 1 by 3. 1 by 3 is a rational number because p and q are both are integers and q not equal to 0. That's why this number is satisfied the condition of the rational number definition. Okay, therefore 0.333 is nothing but 1 by 3. Is this clear, my dears? This is clear? Do you understand that? Right. Now, children, let us discuss some questions from the exercise 1.3. Question number 1.
write the following in decimal form and say what kind of decimal expansion each has.
Whether it is a terminating decimal or non-terminating recurring decimal that we are going to discuss. Now just simple division solution. Now see this here. Given that 36 by 100. Now when you divide 36 with 100, you will get, see this 36 is not possible. So therefore, if 36 is not possible, take a decimal point, 0 here, 103 is 300. Now when you subtract, 60 will become, decimal is there, 0, 600. 106 is 600. Here we got remainder is 0. So therefore, it is a terminating decimal. It is a terminating. That is. Now coming to your solution. Given that 2 by 11. When you divide 2 with 11. 0.0, 11 ones are 11, 9, 0, 11 nines are, 11 eights are, 88, okay, 2, 0, again 11 ones are 11, again 9, so here it is going to become 9, so 0, 11 eights are 88, so now again you will get that is 2, so it is here the digits are in the quotient 18 is repeated and remainders are 192. So that is 92 is repeated. So therefore it is a non-terminating recurring number or non-terminating recurring decimal expansion. This is clear, my dears? Which type of expansion here? This is a terminating decimal expansion and this is a non-terminating recurring decimal expansion. This is clear, my dears? Now, children, I hope you understood that today whatever we discussed. Clear? So now that is terminating when remainder becomes 0. What will be called? That is a terminating decimal. When remainder never becomes 0, that type of numbers are called non-terminating recurring decimal expansion. Is this clear, my dears? I hope you understood that today's topic. And here is homework today. Please note down textbook page number 14, exercise 1.3, question number 1, second bit, third bit, fourth bit, and sixth bit. And question number 2, question number 3, question number 4. Please complete this homework in your classwork. Clear, my dears? Thank you. Have a nice day.